Good morning. My name is Meg Detloff, and I work for USGS PNAMP. Thanks for joining us today for the PNAMP Fish Monitoring Work Group Juvenile Density, Snorkel, and Electrofishing Task Team. A couple of housekeeping tips before we get started. Please mute yourself by clicking on the microphone icon. You can see it on the screen up here on your Teams platform. If you're on the phone, just use *6. Also, please turn off your camera if you're not speaking. If you don't see the toolbar, try moving your mouse and it should pop up on the top or the bottom of the screen. The bar should be similar to what you see here. If you have questions or feedback, please use the chat function or raise your hand and unmute yourself. We can unmute you, but we cannot unmute you. We're recording the meeting and it will be available on our YouTube channel later this week. If you're having trouble with the chat function, here's a couple of troubleshooting tips. Try leaving and joining the meeting again. Use a different browser. If you're in Chrome, Edge seems to work better. Or try using the desktop version or browser or vice versa. And with that, I'm going to have our task leads turn their cameras on and introduce themselves.
One of your task leads, this is Russell Scranton with Bonneville Power Administration.
Casey Blazner, Oregon Department of Fish and Wildlife.
And I don't know if Marika's out there. Marika Dobos from IDF&G is part of this task team too as a lead, but I don't think she's available today to be here. Yes, I think you're talking. Are you muted?
I just sent, this is Jen. I sent Marika a reminder. So I can't recall, Meg, if she told us she was unavailable.
Oh, hey, Marika.
Sorry, who's talking about you?
I heard, geez.
All right, awesome. And now that you guys have introduced yourselves, it is your turn, participants in the crowd. So don't worry about turning on your cameras or mics. Simply open up your chat function and then introduce yourself with name and organization. This kind of helps acquaint you with the chat function and helps us keep track of participation. And while you guys are doing that, I'll just kind of quickly cover the agenda. Russell will kick the meeting off today with a recap of the draft juvenile density concept spreadsheet that we've kind of been working on for the past couple of months, and then lead a discussion on the document. And then next up, we have Dan Isaak, a research fisheries scientist from U.S. Forest Service, and he's going to present his fish density analysis tool for us and let you guys ask some questions and kind of get some more information about that. And then after that, we're going to wrap up with just next steps. And with that, I will hand it off to Russell Scranton.
Thank you, Meg. I'm going to hit, see if everything functions. I'll share my screen and I'll see which screen I'm sharing and we'll see if everybody can see it.
Perfect. Sounds good.
And it looks like it's sharing the wrong window. Do you see a nice blue desktop with nothing on it except for a bunch of icons?
Yeah. Okay. And now I can see your Word doc. Yep, there you
go. Thank you. Thank you, Meg. This group we've got together in the past and we've done some initial work with IDF&G, ODF&W, with BPA for 2 tasks. And sharing and exchanging snorkel and electrofishing data. And we initially came up with some data fields in order to share the data, use it in some common tools. We've proposed a controlled vocabulary for supporting development of a data exchange standard. There's been ideas of sharing that with StreamNet, making it fit to the StreamNet data query and other things, but that's something that's still to be determined. But the minimum thing after our discussions with IDF&G, ODF&W, we have Dan Isaak, we have Brian Mashoff, myself, we've tested this and we tried to come up with, oops, it looks like oh no, the categories there. We have some spreadsheet, and we've transposed it into a Word document for some initial information and feedback. And the basic information we've put into several categories of stream reach information, organization information, metadata, observation, species information. You'll see as I go through this, the general categories. We recognize that not all data is collected, but to help, if information is shared, exchanged, and stored, some information may be auto-populated, like species information based on location data or other codes, to comply with StreamNet standards. So there are things that we have. There's lots of fields. Some are optional, some are required. The optional fields we find are useful or are common in people's data collection efforts, but at this time may not be used in data tools or analytical tools that we've observed that have a common need. But what we're hoping to do is get feedback from everybody else today about these data fields, what's optional, what should be collected and maintained. And we have a field that's required and optional within this data set as well. We've gone through, and I'm missing one component, this version of the Word document. I'm missing some of IDFMG's data. We do have it. I will update it. I have ODF and W data set, and we've gone through and confirmed if it fits into the StreamNet, which ones fit into the current StreamNet database data structure, and which elements don't. But the general information that we've had and what we want to talk about is for each of these sections, what seems like easy information that everybody does collect, we think is generally required, and what are some of the problems that we've observed with that information as far as regional integration or consumption. So the examples that we have, there, Meg, can you do me a favor actually? The file that I'm looking at is the one that Mike Bannock just sent back, and with StreamNet, and this doesn't have the last edit of the thing that you and I worked on. So I'm wondering if you can work in the background and double check and open up the last version that you have on the file to see it. The things that we've identified, we have our stream name, stream ID and code, and the source. And one of the things that was important is that for exchanging information, we need to know the, and for potential use and application and tools, having that, the ability to make sure that you have a specific site linked to a stream name, linked to some common format, whether it's NHD or the StreamNet layer. There is a new hydrologic layer that NOAA is using that we need to potentially discuss. So what is that source? What is that name of those files that we're looking at? And then specifically, when it comes to your data, everybody should have a specific site reach name or a specific, specific ID associated with their survey. The additional information that we get is latitude and longitude. There is a question about the site identification method. Is it the start of transect, end of transect, midpoint, centroid? That's optional. We do request to have the datum because one of the things that we've found is making sure that the points are accurate. If a point is using a different datum, it can be as much as up to 300 feet in difference. And one of the reasons we're looking at common stream names is if people just provide a site and that point ends up moving or goes over a tributary or something else, it's not necessarily clear which stream network that may apply to. So that's the basic information associated with the site and reach information that we're looking at. And then when we come down further, we are looking at trap and sampling event information. Who is the data owner in context? Who's the main leads, typically who manage the information if you have a question to acquire it, or whoever signs off on validating it. The organization name, the observation date, we put that as a month, day, year sampling format. This may change whether or not there's PNAMPs has some recommendations on dates and times of how to format that, but we'll have some discussion hopefully here. Other fields that are sample start time, sample end time, survey year, survey event notes, sample event ID, dataset ID, those are all optional. One of the things that we do require or asking people to provide is a survey type. And this list we're hoping to increase. It's just a suggested pick list, but with everybody's feedback, we're hoping to make sure we have some clarity, because the difference of a survey type, whether it's electrofishing single pass, multi-pass, or a standard, there's a lot of different survey types that people put in here, and understanding that term relative to different approaches is important. And whether snorkel surveys, whether people are using hook and line for marker capture or other information associated with trying to capture their fish. We do have a link here, and this is also, we've moved this. This is also moved down to the bottom of the documented metadata, but there's a study plan protocol link. We're working with PNAMP and it's required. We're trying to figure out what's the best way to document this. There's an alternative from the past with StreamNet with this, which was a protocol name and link, and we're trying to update that to study plan and design / protocol link. So there's an alternative definition for this. So that's the basic information that we've initially identified for the trap. Sorry, this should be for the. It shouldn't be for. It's a sample event information. The species information that we're looking at, we've run into some interesting species identification issues. And how different entities and organizations document that, whether it's just the common name and run, and these two elements are used by StreamNet in the coordinated assessments, or if people are using species codes, and examples are, we have Patagus, and there is also a genetics group that if they're using a specific code, like ODF&W's dataset uses 11W to mark for wild Chinook, then people may document this information. And while these species codes and the derived names may be optional, if that information is entered, we're hoping that through an exchange or some standards that if we have a list of these codes, we can convert that into a standard name for the run or the common name for the fish species that you're looking at. And we recognize that run may not necessarily be identifiable, but it's optional for the species. If you're doing snorkel and electrofishing, if it's a spring Chinook, fall Chinook, or summer Chinook, it may not be possible to tell the difference. The information associated with the ESUs, recovery domains, major population groups, and populations, and these all come from coordinated assessments. These should be derived information based on the location and the species. So if you have a latitude and longitude and a specific species name, all that information should be able to be auto-populated if exchanged to a common location. Then I think this one got put into the wrong category, but origin should be part of the species information. When it came to abundance, there were some questions that we had for fish ID or information that's associated when people do documentation of abundance. When people are doing electrofishing, there is a fish ID. There is size classification and numbers counted. Those are the general minimum information that was identified from a data collection event. There is also a desire to capture efficiency, which is the primary type for efficiency if it's recaptures, and examples with ODF and WWs that they did not have recaptures. And the extra information that we're looking for is correction factor or observer error, or additional information on these numbers that are estimated based on the the numbers that are counted compared to the correction factor to give you an estimated number. In these exchanges, the next component that we're looking at for field data is the sample unit size. So what type of channel are you looking at? The site or reach length, the site or reach average width, and the site or reach average depth. These two, the reach length and width, we're proposing as required. The reach depth we're proposing as optional. And with that information, then we are trying to capture the observed information of fish per meter squared, fish per meter cubed. This can all be automated and calculated based on the information provided above. There has been some questions and information specifically, and I hope to get some feedback here, that when we're dealing with decimals, when we get into fish per meter, we've seen people round their data up. But if we were to put this at fish per 10 meters or fish per 100 meters, that number is significant. And we think that it's important to make sure that we capture it within a decimal place, but trying to make sure we have some agreement as to how many significant figures is important, because counting 0.01 fish in fish per meters isn't necessarily believable by some people, but the reality is if you have 100-meter surveys, that number is probably realistic for fish per meter if extrapolated to a larger distance. Again, in this exchange, and the idea that we're proposing is that you have the observed counts converted for fish per meters. We also like to look at proposing that there'd be an estimated abundance, the derived value as well, based on any correction factors that are provided. And then we'd look at having the dataset metadata, which includes org, program name, project names, ID numbers, who's the biologist or person who collected the data, their contact information, a URL for that, for the data set, as well as the data repository name. We have, again, I think clarification that we're working on was the protocol method, protocol reference, survey method, whether it's a Snorkel survey or the survey type, whether it's a panel, a core, census, resident, annual. There's lots of different terms that people are coming up with, and we want to make sure that that's documented for the ability to look through the information. There's also a proposal to have a related link to the annual report or anything that's related to summarization of the data. So this is the initial file that we had proposed. I'm hoping there's a Meg, if you can jump in, we might want to change back to the other file on the system that we were working through last. So that's the initial discussion. We're hoping today we can get some more feedback from everybody and go through the different sections to determine if there is any suggestions or pinch points or problems with any of these fields, what doesn't seem realistic to capture or share and exchange.
Hey Russ, thanks. This is Jen Bayer, and I just want to add, I'm hearing an echo. Is everyone else hearing an echo?
Yeah.
Shoot.
Okay, it's better now.
Okay. I want to add that the idea of this is to create a template so that information can be shared more easily. And I know Russ said this, but I want to make it clear, we are not building a exchange standard that would be automated and flow at this point. What we're at like a step before that. We don't know if that's warranted. We don't always need to have automated flows, but this is to help people be able to share consistent information and create a structure so we know what is important to be documented. And anytime that there's an element, you know, like one item in this row here that is already published as a standard somewhere else, like date and time, we're going to ask that we converge with that. So there is an international standard for date and time. We're going to recommend that's the standard that everyone follows in this template. It doesn't mean that in your own organization anything would have to change. What we're striving for is just good documentation so that we can map from one system to another. So you can do the date however you want. You can spell it out in letters and whatever, or you could do it in month, day, or you could do it in the international standard, as long as it's defined so that you can much more easily map from one to the other. So we don't want people, you know, no one's being forced to do anything different back home. We're simply trying to encourage consistent documentation and where we can converge on definitions. So we know that we're actually talking about the same thing, whatever label you use. So there's a lot that Russ ran through. Sorry, Russ, to interrupt, but I want people to understand the context before we move on.
Yeah, and just as an example, and I'll just speak quickly on this, is Jen, when we gave this to StreamNet, they were looking specifically at the data exchange for the data query related in trends, but all of these terms and all of these definitions for recovery domain, ESU, DPS, MPG, all of these definitions and fields come from the StreamNet data field. So as Jen said, we want to discuss making sure that these are consistent. So when it comes to sampling dates, we want to make sure that if there is a recommended standard, that we can all agree to that and have that feedback to change this and convert that and try to put it into the right format.
Yeah, Jake, I see your hands up. Go ahead.
Thanks. Just have mainly a comment. There's quite a bit to absorb here, so I don't have an initial gut reaction, but I'm curious what the plan is from after today. I see a lot of overlap with some existing DES fields and whatnot. Are you going to propose that a DES technical team from each state and tribe and whatnot take a close look at this to see, you know, where there's some overlap and, you know, what makes sense, and be able to gather more data sets within our own agencies to get a better idea if a lot of this information will fit?
Thanks. That's a perfect question, because I think we didn't talk about, we jumped right into this section without discussion, kind of the overall scope of what's going to happen today. Part of this effort is that I think we would like to propose to have different entities and everybody come in to a file that we will share after this meeting to see if you can populate it, if it makes sense, if there's problems with it, and if something should change, if the definition is wrong, if we can update pick lists, whatever it is that we can come up with. But the main core issue that we're looking for is, do we have a common field name that can map to something that is in your data system? And the second part of this is that later you're going to see a presentation from Dan Isaak. We are hoping, we have coordinated with IDF&G and ODF&W in the past to run a model and an output, and have acquired data in this format from all of them in the past. What we're hoping to do is, if this structure looks doable, that, you know, one is to get a comment on the structure and the feedback for something that might be a data exchange, and then discussing that. But the other is for a data call, that if anybody wants to provide data in this format, it can then be consumed and used in 2 data tools One that Dan's using as a concept to look at, fish densities, modeled fish densities across the basin. And you'll see that presentation this afternoon. But we're trying to expand that model and assessment from Idaho and the upper Grand Ronde areas of Northeast Oregon and John Day to a broader Columbia Basin and even Pacific Northwest expansion for Steelhead and Chinook. So you'll see that this afternoon. But I think those are the two outputs that we're trying to look for. One is these fields, and potentially, if people are willing to and provide actual data in this format or something that can map to this format.
But Jake, it's voluntary, and we don't have the funding in place like we did for the hatchery CAX work, where we were able to support people's time. We don't have that at this point for this. So I don't want people to feel pressured, but we do. It is an opportunity, and we know the topic is of interest to a lot of entities. So that's where we are right now, Jake. Good question.
I appreciate it. Thanks for clarifying.
And
it makes sense now. Thank you.
And Jake, I think one of the other comments is, with ODFW as an example, we were talking with Jim Rizicki in the past, who's now retired. But we were talking with Casey Bleasner, Jim, ODFW's Grand Ronde, and John Day's leads, and trying to come up with some common data structure for them because they didn't have it. Each of those basins had a different structure, exchanging their data between that and coming up with some recommendations of where they could store their data to provide some more common use was, a potential outcome that we identified as a justification for trying to work on this standard. So, and I think it would be more than just, and we were hoping also to add in the Umatilla, but that comes into the Deschutes and other basins, and even Willamette and Oregon coast. How do we potentially collaborate with them for other analysis? But keeping the floor open, I think just want to do a quick check. Meg, how much more time do we have on this? I think this was just an intro, or we can spend some more time to discuss these data fields and questions that people may have.
Let me check real quick here. Dan was going to start at 10:35, so you've got 5 minutes, or Dan can just start early. Dan, I see your hands up. Go ahead.
Yeah, Russell, I guess had a question about one of the fields, and it was close to where you are now, but for the reach or sample locations and say the lat longe, or however that's spatially approximated, we might want to have some additional clarification there about whether that information is for the beginning of a reach, end of a reach, or the centroid. Just for longer sections of stream, at least, that those can be quite different. And so whether that's a drop down or just a comment field that clarifies exactly the spatial information being provided, it would probably be useful.
Yeah, we provided that as the next field, which was the site identification method, was at the start of the transect, end of transect, midpoint, centroid. So whatever point is provided. And PNAMP, we have a list along with date and time. There was a location document a long time ago that gave a pick list. I could not find it, and we're still looking to come up with this list of some standard options that people could use or write in their own text for how that site was identified.
We can share what we call the MMX, the monitoring metadata exchange standard we wrote to bring sites into MR. We can share that with you, Russell. And then more recently, we've done additional work on this in the habitat metric work that we've been doing with Forest Service, BLM, and EPA. So that's not published yet, but it will be soon. So we're just trying to get people to converge. So right now we're all looking for feedback from the experts out here on this call. Like, do you see any red flags? Is one question. And then a second question is this something of interest that you would be willing to work on? Because it it takes time to proceed through this, and we will want people, more eyes on it, the better.
And then Casey Justice put a comment and question in the chat. I had the same thought as Dan Isaak. Should the site identification method be required?
Probably.
Okay.
Most people don't have it in their data systems to date. So I think
Ah.
that's something that could be added. And if we require it, I think that's just something moving forward that many people haven't identified in their data sets. So ODF&W and IDF&G and their data systems don't have this as a data field, but it may be simple enough that there is directions that each of their sites are identified in a standard format. It's just that it wasn't documented in their data system. So.
Hey, Casey, I see you have your hand up now. Go ahead.
Yeah, thank you. I had a question about the fish size categories. Curious, if you could give us a rough idea of like what level of precision you're thinking for that. I've seen protocols that are trying to estimate fish size from snorkel surveys as small as 5 millimeter categories. So I'm curious what you guys have thought about with that.
Yeah,
Larger bin sizes would be great from my perspective.
We just have it as a standard field that there is something that documents the size classification provided. We are not trying to standardize it. Just as an example, like in one of the data sets from ODF&W, they have a range of 130 to 199 for Chinook. I have one of the tools I have for a visualization that I can't seem to be opening right now. It just shows that we have lots of different size classifications for different species by different organizations. And maybe it will be something that we can come to a common recommendation in the future, but that's not where we're looking at. We're just trying to capture the field. So we know that if somebody uploads their data, this was their size classification for this many fish. So.
Okay, thank you.
But I think that will potentially lead to something, maybe if there's a greater need to have common size bins and classifications for certain species, maybe that will start that conversation.
Okay, awesome. Sounds like you guys are kind of winding down and getting ready for Dan. Let's see. This over real quick.
I'll stop sharing. Or you've taken it. Thank you.
Yeah, I snagged it from you. Next up, we have Dan Isaak. He's going to present on the fish density analysis tool, FDAT, applying spatial stream network models to juvenile Chinook and Steelhead datasets. And Dan, I'll let you go ahead and take care of the screen.
Is that, I guess my slide showing up now?
Yep, perfect.
Okay. Let's see. Okay, so I'll just kind of pick up where Russell left off and try to talk a little bit more about, some of the ways that the data sets that would flow out of kind of having this standardized data exchange standard to build, standardized databases, how some of those data sets could be used. Basically if that comes to fruition and you've got consistent density information for juvenile Chinook or Steelhead across the region, then that's an extremely powerful resource to extract information on status and potential trends from. And so kind of on the side of the work that's being done to develop the DES, we've been working with Russell and BPA the last several years to develop what we call FDAT, or the Fish Density Analysis Tool. And that's basically applying SSN or spatial statistical network models to juvenile density data sets to basically link covariates to those and better understand what are the factors that are contributing to or driving patterns of density across river networks. And also then once you build those models, you can use them to extrapolate to the full network and create information at a broader spatial scale. And so Aaron Peterson, Jay Verhoof, and then some of the GIS folks here in Boise have been kind of the primary team working on this the last several years. And just, kind of as background where all this started, just the sheer amount of data that's out there now, especially in this part of the world, Pacific Northwest. We've got awesome monitoring programs, lots of agencies focused on awesome cold water fisheries resources. And so there's, literally hundreds, if not thousands of sites that are being surveyed every year in the Northwest, whether it be by electrofishing, snorkeling, or red surveys, to generate density information on, the species that we're focused on managing. And while that, seems like a lot of sites, that are being sampled, and certainly, those are useful, it still kind of pales in comparison to just the overall extent of the network that these organisms live within. Within the Northwest, there's literally a couple 100,000 kilometers of perennial streams. And so, even if we're sampling hundreds or thousands of sites within that, it still represents a small portion of that overall network. And so tools that allow us to kind of expand inference from those sites where we're, dipping in and getting some density information could be, really powerful for giving us a better sense of the overall scope of these populations. And so, doing that sort of thing has been difficult historically because, especially dealing with some of these historical legacy data sets, there's a lot of spatial correlation and clustering that arises just because so many people are collecting data. There's no kind of grand overarching sampling design to it, so you end up with a lot of redundancy in the data sets. And historically, a lot of the models that were developed to provide inference from data sets collected on stream networks didn't account for the actual topology of the networks and flow direction and tributary confluences, those sorts of things. So that's where the work that Aaron and Jay have done, going back 15 or almost 20 years now, have been really instrumental in terms of providing good analytical tools for observation data sets on stream networks. And so that's kind of the foundation that we were building from originally. And originally this was, applied to, say, stream temperature data sets in the Northwest, which, like fish density data sets, there's just thousands of observations out there. And so we had to find a way to extract reliable, unbiased information from those data sets. And I think, one of the things that kind of piqued the interest of Russell was when we did kind of a small pilot program with fish density data sets and published that about 5 years ago. And Russell saw this and saw the immediate potential application for the large fish data sets that exist within the region. But here we're essentially we're just applying the SSN models with an electrofishing data set for trout species in eastern Idaho. We had about 100 sites where we'd done electrofishing, 3-pass removals and estimated densities. And so you can see those on the left side of that graphic, and they're just color coded by the number of fish that were observed at those sites. And you can apply the SSN models to those then to predict the densities at those sites, but then also once you understand the relationship between density and the covariates at those sites, you can use those covariate values to make predictions throughout the full stream network. And that's what's represented there on the right. And so you've got now a continuous map of predicted densities. And then the other interesting thing about the models, that another set of useful information that you can get from them is the confidence or the amount of uncertainty that's associated with those predictions. And if you look at that inset map on the right there, the width of that black margin around the stream is the standard error of the predictions. And so these prediction maps then also give you information about where you are more or less uncertain. So, if you want to use that information maybe in the future to refine where you're collecting additional samples, they potentially are useful for that as well. And so that's a small scale application, but it kind of communicated the potential utility of these SSN models for fish density data sets. And well, I guess one other thing before I move on is just the other benefit then is that these models typically do have better predictive performance than non-spatial models that don't kind of understand the clustering and the location of data on the network relative to that network topology. And so the left part of that graphic shows the observed versus the predicted from just a non-spatial multiple linear regression model versus the right part of that graphic showing the predictive performance from the SSN model that understands, those spatial relationships on the network. And so you see a big predictive boost in terms of the performance of these models applied to these data sets. And so with that kind of as the foundation, we began, thinking about, ways in which you could maybe scale up these sorts of SSN models for application to fish density data sets. And, we came up with this fish density analysis tool, and this list is just kind of a set of what we envisioned as the long-term potential benefits if you could build something like this at scale and then operationalize it. The sorts of components that would include would be the ability to import fish survey data and dynamically correct locations of survey sites as needed. And so that, that would mesh with the DES if we were to build kind of an online tool that operationalized those things on the front end. Then once the data are entered and have been QA/QC'd, there'd be, for people that have worked with SSN models, there's a lot of spatial data processing steps that are then required, and those can potentially be automated and done behind the scenes once we've got kind of an upfront quality data set to work with. Once that's done, you visualize the density data and the survey locations on the network, and then again you could potentially automate some of the fitting of the SSN models once we're confident that those data are input to the system correctly. And then you can output the predictions, just as we showed in the previous slide, of the interpolated density maps, uncertainties that go with that. And then at the back end of this, all that information could be provided as a series of geospatial file formats that could be downloaded and used in auxiliary source of decision support systems. So fish density data would be just one thing potentially that a manager would want to have at their disposal when they're trying to make decisions about where to allocate investment resources to improve habitat. And so this could just be an output file in say ArcGIS format that could be pulled into other sorts of systems to aid in that decision-making process. And so to kind of start down the road of building this FDAT tool and the different components that went into it, we began kind of with baby steps in phase 1 of the project, and some work that Casey Justice and CritFic helped us with in the Grand Ronde by providing a nice juvenile density data set. Also, ODF&W contributed their information for this first phase of the project. And the basic idea here was just to, first, start developing a familiarity with the juvenile density data sets that were out there, getting those formatted in the proper way that is needed for ingestion to the SSN model analysis. And then with this initial data set, just kind of look at it and see whether or not we see the characteristic signs of spatial correlation in these data sets, i.e. the closer that two samples are collected in space, the more similar they are, because that's really the kind of thing that you need to see in these data sets to make it useful for these SSN model analyses. And typically that arises just from the level of spatial clustering you see in the samples on that map. So anytime you're collecting two samples close in space, the likelihood that they're going to be more similar than two samples collected far apart in space is typically going to be pretty high. And so we wanted to check that with this initial stage of the project, fit some initial models. And then Aaron Peterson also did some work to just explore how much of this process could be automated in terms of, calculating the SSN models and doing some of the data pre-processing steps behind the scenes once you had those initial QA/QC steps undertaken with the data set. So that all went well. I'm not going to talk, a lot about the specific results from phase 1, just because it was kind of a smaller data set to begin with, and we were just trying to feel our way through the process. And it ultimately became folded into this larger scale application in phase 2 of the FDAT project. And here we were just, scaling up the approach, included the John Day as well as the Grand Ronde, and then all of the Chinook and Steelhead habitat within the state of Idaho. And here the objective was, just to see, again, is this approach going to work with these larger data sets? Also to test a much wider range of potential covariate predictors in the model. And And then also assess whether, once you go through a model selection process and you're looking at the associations between those covariates and densities, are the outputs you're getting from that ecologically realistic? Are we seeing habitat relationships that would kind of be close to what we would expect for Chinook or Steelhead, or are we getting nonsense out of the model? So I want to take a close look at that again, before scaling up and investing a lot in this potentially regionally. Are the outcomes going to make sense? And then also going through this process of applying to larger data sets, refine some of the software that we use to fit the SSN models to be more computationally efficient, because it does take a long time to get a model fit with some of these larger data sets. And so in this example then for phase 2, we had a much larger data set contributed by Idaho Fish and Game, Forest Service. Biomark gave us some data in addition to the CritFic and ODF&W data that we had from Oregon. So here we're looking at almost, well, more than 2,000, almost 3,000 unique stream sites for these two species. And then, some of the sites are surveyed repeat years. And so almost 7,000 to 7,400 total samples for both juvenile Chinook and Steelhead to be playing with in this phase 2 of the project. And just visualizing the data sets, this is what they would look like. You put a dot on the map and then you color code those dots by the number of juveniles at different sites. And here you're just getting a sense of that. This would be kind of the initial outputs that could be envisioned from a DES once all the data are integrated and standardized. That this would be the sort of thing that would come from marrying that DES with the FDAT tool that kind of upfront you could visualize and just look at the data once it's been entered to the system. And then covariates, don't want to spend a lot of time on these, but basically we just tried in this phase of the project to throw the kitchen sink at the models here and come up with everything that we could possibly conceive and quantify from geospatial data sets in a consistent way across the project area. Because we had a large sample size here, so we're going to be developing models that have good statistical power, and that then allows us to kind of sort through these things and figure out what's going to be important ultimately for a sort of regional scale application. But the basic categories of variables there that we're looking at on the left are hydrologic attributes, so mean flow or mean summer flow or winter high flows, temperature conditions, water quality such as stream conductivity, land use, morphology types of variables, so reach slope, road densities, etc. So a lot of different things there. And one of the limitations to doing this, of course, at these broad spatial scales is sometimes you can't bring in the level of nuance ultimately you would like to have in this sort of spatial analysis, just because it's difficult in some cases to quantify these things that we all know are important for fish habitat in a geospatial format and do so consistently across broad areas. So at some level there are limitations here with representing kind of local site scale characteristics. But anyways, that's the kitchen sink approach in terms of trying to derive everything we could, put those into the models to predict the densities of these two species at these thousands of sites. These are the sorts of predictive accuracies that we saw coming out of the models. It's not that we can account for everything, but at the same time, the predictive ability here, almost 50% for steelhead densities and almost 60% for Chinook densities is pretty good, I would argue, from data sets like this that are collected using different sorts of sampling techniques. There's electrofishing data in here, there's snorkeling data in here. Some of it's been corrected for abundance, others are just kind of the raw counts. And so there's a lot of inconsistencies still in the data set, but at the end of the day you can still extract a lot of useful information from it. And in both cases here, we're seeing that explanatory ability being on par with what we saw in that smaller data set of 100 trout electrofishing sites that we used in the initial pilot project. So, in that case, all the data were standardized, collected the exact same way. And here, even though we don't have some of that similar quality control on the top end, we still end up with pretty good predictability. Oh, and I guess one other point about this, and I alluded to that in the goal statement for this particular phase of project, was working to refine and update some of the computational routines that are used for these SSN model fits. You know, the original set of software scripts we used to fit to these large data sets took about a week to fit the model one time to these, you know, thousands of observations. But over the course of this project, Jay Verhoof, who's the statistician that's part of our team, developed some new model code that basically speeds that whole process up by, you know, a factor of 10. And so instead of it taking a week, now it was taking a few hours to fit these sorts of data sets. And so that's kind of one of the, you know, big advantages that we're seeing already from applying some resources to integrating these models with these large data sets. In terms of the ecological relationships, you know, the SSN models in many ways are kind of like a multiple linear regression in that you're going to get a series of response curves out of the model that just show the relationship between the covariate predictors and the attribute that you're predicting, in this case, juvenile Chinook densities, or expressed as number of fish per 100-meter length of stream. And so, you know, we saw that previous slide looking at lots of different covariates. At the end of the analysis, these were the 7 that came out as being statistically significant for juvenile Chinook. And basically, if you look across all those and kind of summarize what it means, you know, the model's basically saying that juvenile densities are highest in kind of medium-sized cool streams that are lower gradient and have, you know, intermediate amounts of canopy and base flow conditions. And so, you know, that pretty well matches, I think, what most of us would think of as, you know, good spawning and rearing habitat for Chinook. For Steelhead, you know, it was kind of a similar situation in terms of a lot of the same variables were driving the model and ended up being statistically significant. But the interesting thing here was that the response curves looked different, even though those relationships were statistically significant in both cases. So if I just flip between these, you know, a few times, you can see how those response curves change for the two species. And, you know, the take home for the Steelhead model is that densities were highest in streams that are smaller than Chinook and a little bit warmer and have, you know, slightly higher gradients and proportions of canopy. And so again, I think pretty well matches what we would expect ecologically from this species versus Chinook. And then once you fit the model, you know, you've got it linked to covariates at the observation sites, and those covariates then are all represented geospatially throughout the full stream network. You can then use those covariate values on the model equation to make that interpolated density surface. And that then is what this graphic represents for juvenile Chinook densities. Again, just color-coded by the predicted abundances of Chinook. And so the places that are colored red are kind of hotspots in terms of having higher densities of juvenile Chinook, and then the blue colors are places where the densities are lower. And then this is the same sort of map then for juvenile Steelhead. And here, a couple interesting things, I guess, compared to Chinook. You know, if I just flip between these two slides again, you kind of see that the potential habitat networks that we're looking at are different. You know, the Steelhead habitat network's a lot denser because they do extend farther upstream into smaller and steeper gradient streams. And the networks that we're looking at here are I should mention, based on the StreamNet species distribution layer. So that's ultimately what's providing the foundation of what we're modeling. And then the other thing that's interesting to see is that you can see the highest densities of Steelhead, you know, typically occur in Oregon, where the streams probably on average are a little warmer than they are in Idaho. And then you kind of look at the Chinook density map, and it's a little more spotty. But again, that matches with what we'd expect based on the response curve describing optimum temperatures for steelheads, that they do generally like a little bit warmer streams than do Chinook. And so those previous maps were density scenarios representing kind of average densities across, I think, the years 2000 to 2018, just average densities across all those years. But then you can also make different sorts of scenarios, right, representing individual years. And so we've done that as part of this phase 2 project. And then also because we've got some understanding of those habitat relationships, we thought it'd be useful in this case to also create some future climate change scenarios. And so we created a series of density scenarios representing, how densities would shift potentially based on 1 degree, 2 degree, or 3 degrees Celsius future temperature increases. And then the sorts of things that these density scenarios can be used for, just to kind of wrap things up. One of the things that then is nice is you've got a consistent density map for given scenario that you can lay down on different river basins across the project area, and you can combine that with information from other tools that have been developed within the region. So one of the interesting comparisons I always thought was useful was some of the information that Russell showed from the 1 fish 2 fish and the intrinsic potential mapping. That there, in that case, you've got information about, well, this is how many fish potentially could be in a reach stream versus now the FDAT information from these density surveys gives us information about how many fish actually do occur within a reach stream. And so just making a comparison between that IP versus observed, and maybe the size of the difference between the two gives a hint about that being a place maybe to look at a little more closely and say, if it's not reaching its potential capacity, why is that, and is that a place that maybe you'd want to invest resources? Another thing that information can be used for is a climate change sensitivity analysis. And so as we think about things getting warmer going forward, since temperature does show up in these models as having an important effect on the densities of these organisms, you can model what these densities might do in terms of changing as it gets warmer in the future. And so in this case, then we're just looking at a difference map between that baseline scenario and a future scenario representing a 2 degrees Celsius temperature increase. And then we're mapping the change in predicted densities across the Chinook streams. And so places that are color-coded green here are places where densities are predicted to actually increase in the future as it gets warmer and it moves into more of the optimal range for Chinook. And places that are color-coded red are reaches where we'd predict that it's already a little bit warm, maybe a little warmer than optimal for Chinook. And so as it gets even warmer in the future, we would predict that densities are probably going to decrease in places like that, unless, of course, we can step in and do something from a habitat restoration standpoint to better shade those streams or maybe increase flow or something to offset those future temperature increases. And kind of the last big thing that I think that these sorts of SSN models apply to these density data sets are useful for is developing larger scale population estimates. And so because you've now got these continuous maps of densities across the river network, you can sum up that information at whatever spatial scale is most useful. So if you wanted to develop a grand population estimate for this whole phase 2 population area, you could do that. Or in this case, we've applied some of the population area boundaries, I think, that were, I don't know, developed by the TRT, or I guess I'm not sure exactly where these boundaries come from, but you basically just cookie cuttering and applying these boundaries to these density maps, and you can then derive the total number of fish that are estimated to be in some of these areas, as well as providing confidence bounds on that. And then also again, if you want to tie that to kind of a climate change scenario, you can look at here's what it is now, and then in the future for across this population area, this is what we'd expect maybe the population size to do in the future. Some places, because they're really cold now, might become better habitat in the future, and conversely, places that are warm now might become worse in the future. But again, the tools then just provide a way of making that sort of inference in a unbiased way across these larger areas. And so for the next phase of the project, phase 3, basically we're talking about continuing to expand this geographically now to try to include the entire Pacific Northwest, again relying on the StreamNet data or species distribution layers to provide kind of the foundation of what we work off of. And so now expanding to cover the rest of Oregon, Washington, and then by including or starting to look at bull trout, starting to work in northern Idaho and northwest Montana. And a couple different things then that we're proposing to do within that geographic scope is firstly, that second objective, to apply the existing SSN density models, because they have been, essentially calibrated to some really large steelhead and juvenile Chinook data sets now. Assuming that those habitat relationships, represent what these two species like across larger portions of their range, we can apply those models across this broader geographic area to develop a consistent set of density scenarios. Just with what we've already done, once we kind of tune up and integrate some of the existing StreamNet data or distribution layers to work with the SSN models. And so we can do that without having developed new models. We're just applying what would already exist. In that third objective, then, we are proposing to integrate new juvenile density surveys from these new areas and refit the models. And so that then goes back to the idea of this DES and making it easier to standardize and format existing data sets and contribute them to this project, because we can do that in Washington or coastal areas of Oregon. That typically is the most time-consuming part of the process of fitting these models, is actually just getting the data sets organized on the front end. And so, if we can do that, we would then progress to refitting the models across the broader area and providing, a similar set of density scenarios, but those are going to be a little more accurate if we can bring in new information. And then the fourth objective or main objective of this, phase 3 of the next project then is just beginning to explore SSN model applications to some bull trout density surveys, like we did kind of in phase 1 and then phase 2 of the project for juvenile steelhead and Chinook. And I think, I mentioned already, but really, kind of the key to, expanding on this phase 3 and, stepping towards operationalizing, the tool in a way that's kind of dynamic and makes everything more streamlined and efficient, from the user to the modeler to the outputs, is this DES and getting people to buy into that, refining it to the point where people are comfortable using it and the fields that are there. And then if we can get to a point ideally where we're caught up on all the legacy fish density data sets in the region, and then we're just having to do kind of annual updates, but people are used to using the system, then we could be generating this sort of spatially consistent and broad scale density information for juveniles on a regular basis, to provide regional status assessments. And then over time you can start stacking those individual years on top of one another, and that then provides the capability of looking at trends at individual sites or across the whole basin. So there's a lot of potential utility, I think, in integrating these SSN models with a standardized data exchange standard and starting to generate this information for users across the basin. And then these are just kind of the potential advantages of that fully functional FDAT system. Already talked, about a lot of these, and so I won't step through this again, but basically we're just trying to find a way to bring to bear some of these tools on the large data sets that are in the basin and make it a less painful but more productive process for everyone that's collecting these sorts of data sets. And I think that's all I've got. So.
All right, awesome. Thanks, Dan. That was a fantastic presentation. We're going to go ahead and open up the floor. So if you guys want to type a question in the chat, if you guys want to turn your cameras on and ask questions to Dan, feel free. Russ, I see you got your hand up. Go ahead.
Yeah, Dan, there's two quick things. Just for this group to understanding, one of the processes that you have to deal with, and I think what's helpful is, as you mentioned, the need to identify the site and the type of site identification process that's used, because your process, when you get a point on from a specific location, attaching it to your stream network, and you're using the NHD layer. And if somebody has the StreamNet layer, and the stream names may match, they may not match, there may be some things going on, but being able to identify and attach that to a specific stream reach ID, whatever temperatures associated with all those other attributes depends on where the centroid, the start point, or whatever is identified. And so I just wondered if you could talk about that process as well, because that's not automated yet. It's a manual process. And the other component is if you get a bunch of additional data, one of the things that this helps do is we were talking about using new data to test and validate the model outputs. So the idea and the concept is if you run the network, show what your predictions are, and you get actual data. I think this is one of the points that we have in a carrying capacity work group. So there's another group with PNAMP. We're working on a carrying best practices for looking at carrying capacity fish densities. We're looking at trying to document those processes to test and make sure that the predictions are correct. So there's two topics for if you can briefly talk about.
Yeah, well, I think the first one about providing georeference information, that's one of the big challenges of kind of going through these legacy data sets now that every agency has and we have collectively across the region. Is there hasn't been a standard way of recording that information or integrating it into agency specific databases. And so typically when we go through this process the first time, it's messy and it's time intensive because some of these things you can look at and understand, other ones you don't know exactly what you're dealing with, and so you have to go back to and have a dialogue with the people that are providing the data about exactly what it represents, and that's all a time-consuming process to make sure it's done correctly and comes into a database in a way that provides good functionality and consistency. But I don't think there's any way to circumvent that process. You just kind of have to go through it the first time, and by doing that, then everyone starts to understand how useful it is to have a standardized way of recording this information and providing it into a DES. And we get used to then recording information and doing it that way, and then that saves us all collectively time going forward. But our ideal is to have information about the centroid, where is the centroid location of a reach. And then if we've got information about the dimensions of that reach, and we know, okay, this is a centroid, but it's 200 meters long or it's 100 meters long, then that kind of gives us everything that we need to know. If we've got the beginning and end of the reach, we can figure out where the centroid is, but it's not quite as streamlined, and you have to go through a different set of calculations to do that. And so I think one of the useful things coming from the DES is just getting everyone to buy into one consistent way of really recording and providing that information. So you have to do kind of less organization of it and working through it before you can use it in these sorts of modeling applications. And then I guess the second part of your question, I wasn't sure exactly what you wanted me to comment on there. So maybe you could rephrase that a little bit.
Just as far as, the ability to test your models and QA/QC, I think one of the things and the outcomes that we have, one of the things I'm looking for is as we provide more data, people can provide additional data. You can run the model blank without the data, you add it, and it can help validation. I think that was one of the things we identified in the QRF product, and one of the things we were looking at with the carrying capacity work group is ways that people who run these models can help validate and test. And it's based on using actual data and getting that information. So,
yeah, no, I mean, that's kind of the blessing and the curse of all the data that we have in the Northwest, right? Is there's so much of it you can always use a subset of it as a holdout independent sample. You fit the model to most of the data, make predictions, and then you compare it to that holdout sample, and then you can, there's ways of doing that, randomly subsampling from these large data sets, and so there's all kinds of additional value we can tap out of these data if we can build these larger databases in a way that they have that functionality.
Thanks, Dan. And just for everybody's understanding as well, there was one larger thing that we didn't mention is for the FCRPS biological opinion, there's a term and condition that we're supposed to be providing predictions and carrying capacity to help guide and inform restoration. We have a product that was produced for QRF in the region, and having a secondary product to help evaluate and compare that is beneficial. And that's where this outreach to expand the product to the same footprint that the QRF product has will help us to meet some of the terms and conditions that we have. Another output, we can talk about it later and I can share, is that the StreamNet fish distribution layer, which was used when we looked at all the fish data and provided the fish data that sponsors were providing, we showed, I think it was several hundred kilometers of stream that were listed as non-Chinook bearing were actually having Chinook, and it's just changing the footprint of the map that may help guide restoration. So we've used that at BPA to help approve and prioritize restoration in Idaho for people that have restoration projects. So just one way to help improve an understanding of the footprint of where the species are. But we'll let everybody continue to ask questions. Thanks, Dan.
Thanks, Russ and Dan. Brian Mashoff, I see you have your hand up.
Brian, you might be muted.
Yeah, I don't see you muted. You might be something in your settings. Okay, we had, I'm gonna type a question in the chat. Josh Kubo. Sorry, I'm trying to make my screen
Before
open.
you
There we
move
go.
on, hey, Brian, maybe if you're having trouble with your audio and if your question, if you could just write it in the chat, that might be a solution. And I support Meg moving on. We won't forget about you, Brian.
Yeah, we'll swing back for sure. Yeah.
But you could just type it in the chat if that's easy.
All right, so Josh's question was, how are you using or developing correction factors to better align electrofishing data with snorkel data, especially when fish abundance/density was evaluated at a habitat scale rather than a reach scale, and when the target species were in low abundance?
Yeah, no, I mean, that's a great question. And developing those sorts of correction factors isn't something that we're doing in this level of analysis. If those are developed, I suspect, the different agencies that are collecting the empirical data would be the ones doing that at their level. And that's where if that can be done consistently across agency, those abundance estimates derived from the empirical counts, then we could model a more consistent data set and create more accurate density maps. But right now we're dealing with literally everything from the raw counts to sometimes they're abundance corrected. I think some of the CritFic data sets that Casey Justice provided us, that they had been translated to abundances at a reach scale. I guess, correct me if I'm wrong, Casey, but in other cases, we're dealing with raw counts, and we don't have a way at our level of applying a consistent abundance correction without having all the additional ancillary information that we might need, like number of electrofishing passes that were made, all the pools and individual habitat units, et cetera, et cetera. So we just have to deal with aggregated, simpler information at least at this stage of the process. But I saw, Tim Copeland's comment. I like that. And, despite all that, there is a certain amount of GIGO here. The data aren't consistent flowing into it, but coming out of it, we still do get pretty good predictive accuracy. And, I think for people that are familiar with these data sets and they look at those maps, they pretty well correspond with, certainly where red counts occur and where some of the highest densities of spawners occur. And so, there is some utility and validity to the information coming out.
All right, excellent question, Josh. Brian, were you able to get your audio to work? Okay, doesn't seem so. And I don't see anything in the chat, so I can just follow up with you offline, or I mean, you know how to. Oh, here we go. Dan, you showed charts of observed fish log densities versus predicted that had a clear offset of 400 meters y-axis. What does that mean?
Oh yeah, no, I was looking at that earlier today, and I think there's a lot of observed zeros, but that are predicted to be above zero on the y-axis, and so that pulls up that y-intercept, right? So we're not forcing the late well, and so those plots of the observed versus predicted densities, I wasn't forcing the regression line through the origin, so you can get that offset that way.
All right, excellent. All right, I'm going to give you guys just a couple more seconds to raise your hands or ask questions and move along. Oh, Brian's got to follow up. Pressure's on to type fast. If you compute aggregates across EG basins, then you will overestimate.
I guess, yeah, I don't really understand, I guess, from that brief question, but it sounds like maybe something he and I could talk about offline.
Okay, perfect. And Mike Bannock had commented, I noticed a few errors he made in the StreamNet column of Russ's file. They do collect fish / meter fish / square meter fish / cubic meter. All right, excellent. And then Dan and Brian, you guys can touch base. So we are going to move along. Dan, thanks so much for presenting today. That was super amazing. Great talk. I think a lot of people were really interested in hearing this and got a lot of good information back from it. With that, I'm going to hand it over to Russ again to discuss next steps, and then I'll wrap up with just a couple of general fish monitoring work group information tidbits. So go ahead, Russ.
Thanks, Meg. Thanks, Dan. I think, talking with KZ, Marika, and everybody for this team, I think the two things that we're trying to look at is we'll send out, based on a couple comments today, that Word document file, but we're also hand out a different file as well. And you can continue to work on it, but our request, I guess, is for those who are interested, if you have data and would like to test out the exchange or format, provide us comments to help us make some recommendations on standards that would be helpful. If you have fields or definitions or terms that need to be clarified, we can work on that. The main component, as we said, is to support the effort from Dan. This is a unique opportunity where while BPA's funding and focus is really at the interior Columbia, mid-Columbia, the ability to run the tool and run the analysis at a larger scale can happen at once. And so as long as everybody can provide the data to Dan by a certain time frame, we're hoping, Dan, we continue to talk, but February, I think, is what we were looking at. You can correct me, but if anybody can provide their data set for their basin for multiple years or a single year for Chinook, Steelhead, or bull trout, then the goal would be that Dan, when he updates the linear network, updates the populations and expanse, and pulls in the aggregate information for all the covariates, he'll run that data set with a model with your guys' data and provide it as an output. And use your data to help validate that product. So this is just an opportunity to potentially collaborate, share, and have your data entered into the product. We don't necessarily have a guarantee that in the future that this will continue to operate and run. We're going to use this as a example output. So the future updates of these tools may be dependent on the willingness and availability of other people's efforts. This coding in this program will be available, but I think collaborating and working with Dan and his team to help update this will just be a question in the future. But we look forward to anybody's input and feedback on the data exchange standard and providing us data. If you're interested, please reach out to Dan and myself about if you're would like to share your data. And we'll try to make sure that we have a exchange platform where you can send your data on box.com. And our goal is that if you provide it, we'll try to add it into the network and into the tool. So if there's any questions on the DES, any questions on supplying data and you're interested in participating, please reach out to Dan and me. And we look forward to that feedback on the data exchange standard for the whole.
Excellent. Thanks, Russ. And I can provide some of those links and stuff in the follow-up email. And also, just so you guys know, in case you're not watching the chat, Casey Justice provided a link to the model that or the method that they're using in the Grand Ronde. And so I'll send that out in the follow-up email as well. So thanks for that, Casey. And then I will wrap this up. I'm just going to drop a link to the fish monitoring work group page for you guys too.
And Meg,
yeah,
I guess
ahead,
I can share one other piece, which was we had a visualization that Brian worked on using this data to show the general fish densities, I think to help guide restoration, to inform what people had provided as surveys, and the concept to show changes across years to show trends of just observations and densities in trends of fish, but also the comparison of the carrying capacity tools. And we'll continue to share that and provide more of that information in the fish monitoring work group's carrying capacity work group. So if you have more questions and want to participate, we look forward to future discussions there.
Yep, absolutely. Good plug for the carrying capacity group, Russ. So as you guys can see on your screens, here's the task lead contact information again. The meeting summary and recording will be available by Friday. And just a reminder that the full fish monitoring work group will convene January 19th from 10 to 11 a.m. and we'll provide task updates and a presentation from Brian Mashoff. So just some more exciting tools you guys can use to help you kind of manage your data out there. To close out for today, I'd like to give a big thank you to Dan Isaak and our fish monitoring work group task leads, Russell Scranton, Casey Bleasner, and Marie Dobos. And thank you guys, the task team, for joining and participating. We do appreciate you taking time out of your busy day to help develop products and things that'll aid managers and biologists throughout the region. So thanks a lot, guys, and have a great rest of your day.
Actually, before everybody leaves, I think it would be one quick comment. I just want to say, it would be helpful if people do provide us any feedback in the chat. Was this useful? Is this concept interesting? Just making sure there's we have 7 more minutes. So if anybody does want to hang out, follow up, let us know any other comments. We do want to know if this is useful and just get some initial feedback right off the bat. So please hang around for a few minutes if you can, but otherwise, thank you for joining.
Yep, thanks everybody.